So this is a what's called flipped classroom lesson where you'll learn most of the content and skills on your own at home and then come to class and we'll review it and check how you've done, and you can ask questions and refine what you've learned. And we're doing this, as you know, because we didn't get through this in class and we need to keep up with the pace of the curriculum, but we were busy reviewing important, good stuff on exponents. So scientific notation. Scientific notation is a way of expressing values, expressing numbers in a shortened form. A little bit more on that later. Let me just do a couple of examples. I will do the letters of the questions that you're responsible for homework, the letters that you aren't assigned. So you are not assigned B and D, so I'll do those two as examples. First of all, express 53,900 in scientific notation. The way this works quickly, and then I'll explain a little bit more slowly and why it works, is we move the decimal place to be between the first two digits, between, in this case, the 5 and the 3. So we move the decimal point 1, 2, 3, 4 places to be 5.39. We don't have to write the 00 because the 00 will no longer be significant digits when we express this in scientific notation. A little bit more on that later too. So 5.39 times 10 to the power, I don't know what that was, the power of the number of places that we moved. We moved 4. So there we go, 4. That is 53,900 expressed in scientific notation. Let's prove that it worked. Longhand by multiplying 10 to the power of 4 times 5.39. 10 to the power of 4 is, well, just recall 10 to the power of 2 is 100. 10 to the power of 3 is 1,000. 10 to the power of 4 is 10,000. And I think that's not that big of a deal, but just to be clear about it. So let's multiply 10,000 times 5.39. When we do that, I can do this longhand. You can just fast forward through this. We're going to get 0, 0, 0, 0, 9. Drop 1 0 down for the second place multiplication. 1, 2, 3, 4, 3. 2 for this line. Brought down for the third number. 1, 2, 3, 4. And there we go. We add them all up. 2 decimal places to account for. So the final answer of 10,000, which is 10 to the power of 4, 10,000 times 5.39 is indeed 53900, or 53,900. It works. Scientific notation, well, of course, works. Let's do the second example, where we'll be moving the decimal place to the right instead of the left, because we need to get the decimal place between the 6 and the 8. So 0.00680. We'll need to move the decimal place 1, 2, 3 places to the right. So 6.8, the 0 is not significant, times 10 to the negative number of places that we moved the decimal to the right, 3. And to understand why we have to multiply this times negative 3, this is a much bigger value. 6.8 itself is 1,000 times larger than 0.00680. Right? Multiplied together then, we will get what we started with. And let's prove this one as well. So 10 to the minus 1, 0.1. 10 to the minus 2, 0.001. 10 to the minus 3, 0. Oh, jeez, I did that wrong, didn't I? Just let me get rid of the 1, 0 there. Right. So 10 to the power of minus 3 is 0.001. So if I were to test this out to prove, to make sure that it works, I would multiply 6.8 times 0.001. which effectively is that, and we're finished, but we've got 4 decimal places to account for. So 1, 2, 3, 4, deleting 0, 6, 8, and we could add that 0 to it as well. So that may not have been necessary, but there you go. It works. And I think it probably helped to understand why it works. So let's do some more examples. Question 2. You are to do ACE. I'll do, again, B and D. So now we're going the opposite way. What is 2.3 times 10 to the negative 2 in normal or ordinary decimal numbers? Well, negative 2. What we're going to do is make this number what it actually is. And when you multiply something like 2.3 times 10 to the negative 2, you're making the number smaller. We're moving the decimal place 2 to the left in this case. So I'll put a leading 0 here, and it's going to be 0, 2, 3. Next example, 7.931 times 10 to the negative 4. This time we're moving the decimal place 4 to the left. Because again, this is not the quantity. The quantity is this times 10 to the minus 4. It's a quite small quantity. It's way below 0. So if that helps, you remember that you need to move the decimal place to the left. So 4 times. 1, 2, 3, 4. My leading 0. 1, 2, 3, 7, 9, 3, and 1 is the ordinary number, which is represented in scientific notation by 7.931 times 10 to the minus 4. For 3, you are, I don't even have all of 3. I'll just do you do C? No, I'll do C. So 6.8 million meters using scientific notation. Well, 6.38 million is 638,000. That is 6.38 million. Well, we already have the 6.38 times 10 to the how many? It's going to be 1, 2, 3. Whoops, there's that line again. 1, 2, 3, 4, 5, 6. There you go. 10 to the power 6. Which makes sense another way stated, because 10 to the power 6, 2, 3, 1, 2, 3, 10 to the power 6 a million, and this is 6.38 of them. Now that makes sense, 6.38 millions. 4 is kind of more of the same. I could do another one, but I think let's just see what else we have. I think I'll skip that one. And by the way, I'm using a different version here online. It's the 2017 version. You've got the 2014 version of the textbook. So this is number 5 for you, and this is number 6 for you. And you're asked to do A, C, G, K. I'll do B and D again. B and D, or maybe just one of them. What have we got? 4 times 10 to the power of 3. 4 times 10 to the third times 7 times 10 to the fifth. So we're going to multiply the 4 times the 7. You get 28 times 10. Multiplying exponents, as we saw many times today in class, we add. And so there is 28 times 10 to the power of 8, but we want to have just one significant digit to the left of the decimal, so we're shifting the decimal to the right. And I think this is the first time where I'll talk about this. When you're making the number part of the expression to be smaller, you must make the exponent part to be bigger. We moved one decimal place, so we go up 1 power. 2.8 times 10 to the 9th. And why don't I do D actually on second thought, because that was the first time that came up. So 9 times 10 to the minus 5 2. 9 times 6, 54, times 10, same base, 10, 10. The law says we add them, minus 5, minus 2 is going to be minus 7. We are moving the decimal place 1 to the left, 0.4, which is making this number smaller, so we need to make this number bigger. This is a good example. To make this number bigger, it's actually minus 6 in terms of the number 9. 7, you're 7. I'll do, again, B and C. This isn't going too long, I don't think. So what have we got? 9 times 10 to the minus 3. 3 times 10 to the minus 1. So 9 divided by 3 gives us 3. 10 to the minus 3 divided by 10 to the minus 1. When you're dividing bases with exponents, it's the exponents that are subtracted. So we have times 10 to the minus 3 minus minus 1. In other words, 3 times 10 to the minus 3 plus 1 minus 2. See if it's any different or much different. 4 times 10 to the 6th over 2 times 10 to the minus 2. A little different, but basically 2 times 10 to the power of 6 minus minus 2. 2 times 10 to the power of 8. Just a couple more. 8. This is an interesting one. So you are to do all of it. Why don't I just do A? How many times larger is 3 times 10 to the 11th than 3 times 10 to the 8th? Well, the power of 10 differs by 3. And here's where my program started to lag a lot, so I've just started to re-record this over. So we had 10 to the 11th and 10 to the 8th, so the difference is 10 to the 3rd, or 1,000. The one number is 10,000, 1,000 greater than the other. And let me do just one of the 9s, and this will wrap it up. We'll do B. Two point 7 times 10 to the minus 3 times. All right, let's do the ordinary, regular, real number multiplication first. Two decimal places used in the multiplication, 2 decimal places in the answer. And then we've got our 10 minus 3 times 10 to the 14, adding up to plus 14, adding up, and we get 10 to the 11. So the answer is 25.92 times 10 to the 11, put into scientific notation, 2 3 significant figures. So scientific notation, 2.59 is 3 significant figures, and the 9 stays 9 because the 2 doesn't round it up, times 10. Now we've shifted the decimal over once, made this number smaller, makes the exponent larger, in this case by 1. There's your answer. So I hope that helped. Technology is not working the best for me right now, but it'll get better. So hopefully you're good with that, and we'll address it when you get back and smooth out any little wrinkles there might still be.